Good evening, everyone. Today we are having the revision session on week 5 and week 6.
Good evening, ma'am.
Okay, yeah. So, uh, we have studied the continuous random variable, right? Continuous.
Yes, ma'am.
Okay. So, we will discuss some concepts and questions based on that. We will solve that. Okay. So, once you have a continuous random variable, you know that your random variable is continuous and some PDF is given about that. Let's say x is a continuous random variable and we are forming some function of x. That means, let's say y is a function of x. You know the distribution of x. Let's say x is following some distribution. Let's say it's a uniform, the standard uniform distribution, and then you form a random variable y, or there is another random variable which is we are denoting it y is equal to, let's say, 4x square. Okay. What if I say 5x square plus 1? Then if I am interested to know that what the distribution y will follow based on this much information, is it possible to draw any conclusion about this y? If we know that x is a continuous random variable which is following uniform distribution over the interval 0 to 1, and there is one another function defined as 5x square plus 1, then our goal is whether we can conclude or say anything about the distribution of y. So
Yes, ma'am. We can.
what phenomenon we will use to conclude about y? That's our first target when we start with the continuous random variable. So in this lecture, we are going to revise the concepts of this, what we say is functions of continuous random variable, its marginal density, how if there are two random variables, then how we will calculate their marginal densities and conditional densities and all these things. So let's start with first the functions of continuous random variable. So to describe about the distribution of y, what will be our first step? If so, there are two ways. One way is you just directly find out this. Okay, just tell me what will be your line of action if this is the question in front of you, that x is a continuous random variable which is following uniform distribution over 0 to 1, and y is the distribution 5x square plus 1. Then what will be your line of action
And first, we'll
First, we
check if
will
y is
find the
monotonic or not in the given range.
in the given?
this
Given range 0 to 1, y
range.
is monotonic or not.
Okay, that means you are going to use a formula, right?
Yes.
That theorem.
Monotonic, we will
Okay.
check monotonic and differentiable at all the points in the given range or not.
Okay, what is our given range here then?
0
0
to
to
1.
1.
Yeah, that is what we say it as a support of x, right?
Yes.
The
Yes, ma'am.
set of all the values of x for which PDF of x is positive, right?
Yes.
So do we know the PDF of x here?
Yes, ma'am. We know.
Okay. So will you guys try or what?
We can try.
Okay. So I'm just waiting for 1 minute.
Ma'am, I don't understand how to do this problem.
Okay. Yeah. See, in this question, in this particular question, there are two ways. First way is for that. Let's say there is one more function. Okay, for everyone, this is also the same question. X is uniform, following uniform distribution 0 to 1, and there is a random variable y, and there is another random variable z, which is equal to, like say 6x. Okay, this is random variable z. And we want to calculate the distribution. Yeah.
Actually, my basics are not good. I don't even categorize which are continuous and discrete. I always have confusion. So whether
Your voice is broken. See, for the clarification of continuous and discrete, I would suggest you to please watch the previous lectures. But yeah, I will try to describe whatever the question we are going to discuss today. But rest of the
we
distinguished,
we
yeah,
could understand this is continuous and this one is discrete.
okay. So I will just explain you why this particular are continuous. But to learn which random variable is continuous or which is not, for that you have to revisit the previous lectures. Because today we are going to learn some advanced things. Okay, so let's say there are two random variables y and z, which are the functions of x. So whenever this kind of functions are there, let's say z is equal to 6x. Now in this 6x also, you know that this is a monotonic function, but let's say someone is unknown, he or she do not know what the monotonic function is, and they want to solve uh, this kind of questions without using theorem. Then how will you go for that? If your x is a uniform distribution, then I told you, whenever you know the distribution of your continuous random variable, what is your first step? Just find what's the CDF of your given random variable. Okay, so if x is a
Yes, ma'am.
uniform continuous random variable over the closed interval 0 1, then what will be your CDF?
First we will the less than 0 it will be 0, and
Okay,
for the in between 0 to 1 it will be x, and in greater than 0 it will be 1.
0 to 1 it is x, and
X
for rest of the part it will be
greater than
1.
1. 1.
Okay, so yeah, is this fine for everyone? So once you know
Yes.
this, and now you want to find the you want to say anything about the z is equal to distribution of z, then what will be your target? Like the thing, whenever you know the PDF or CDF of a for any random variable, then only you can talk about the distribution of function, right? So now if I want to calculate the CDF of z, then how will I proceed? Fz of z. What do you mean by the CDF? Continuous, sorry, cumulative distribution,
Probability of z less
right?
than equal to z. Yes, ma'am.
Okay. Yeah. For someone who asked me what is continuous random variable, so see, any random variable x is said to be continuous random variable if there exists PDF of x. We denote it by fx by fx of x, PDF, probability density function, which is continuous. Okay, then we claim that x is a continuous random variable. That is like a formal definition of continuous random variable. So fine. So whenever we seek for the CDF of any function, this is the definition. Now, do you know what is your what is the value for z here? So yeah, it is nothing but
6.
6x, which is less or equal to z. Fine. Can we convert the whole thing into x? Yeah. So just divide both side by 6, and we will be like x is less or equal to z by 6. Then now, do you know this term?
We will put the value of Yes, ma'am. We will put the value of x in the upper one CDF to be z upon 6.
Yeah. So
Wherever we see the x, we will put the value of x.
yeah. So can I say this thing as nothing but CDF of x till the point z by 6?
Yes.
So what
Yes,
it
ma'am.
is? So just check with this function. We have write the CDF of x, that is whenever your x lies between 0 to 1, your CDF is x. So what will be here?
0
Z
if
Zero to
z is less than 0 if z is less than z upon
Yeah.
6.
So can I say that this fz of z is nothing but 0 whenever your z is strictly less than 0, z by 6 whenever your z is lying between, yeah, what?
0 to 6.
0 to 6.
Okay. And
And 1
1
when greater than 6.
greater or equal to 6. Fine.
Yes.
Okay. So this was about z when we are not using any theorem and we are just calculating manually. So this is the manual method. If your function is not monotonic or differentiable, at that time you will follow this method. Okay. So let's try to find this y is equal to 5x square plus 1. So if there are this kind of square type kind of terms or cube types of terms are there, at that time try to search whether your function is monotonic or not. So why I am saying that? Because there is a theorem which says that if x is a continuous random variable and y is a function of x, let's say g of x, okay, such that your g of x, that means your function is monotonic, where it should be monotonic,
In the support.
Given
yeah,
range.
in the support of x. Okay, if your g of x is monotonic for the support of x and what, differentiable also, right?
Yes, differentiable at every point in the support of x.
Yeah, and differentiable also, then what?
Then PDF is equal to 1
Then
upon g PDF is equal to
PDF or yeah, PDF of a random variable y, right?
yes, ma'am.
Or x. We know that we know
Y,
PDF of x, right? That's why we will
y,
predict
ma'am.
the y, which is equal to, yeah,
1
1
1 upon
upon,
mod of g inverse of g dash of
no,
x.
G
Sorry, ma'am.
dash
Sorry,
of G
ma'am. G
inverse.
dash of
G
g
dash
inverse
of
of
G inverse.
y. Yes, ma'am.
g inverse of y into,
Fx
Fx
of
of
G inverse
y.
G
G
inverse.
inverse of y.
Of G inverse.
oh, okay, yeah, fx of g inverse of y. What is fx of g inverse of y? It's a PDF, right? And what
PDF,
is g
yes, ma'am.
inverse of y? So just check that I said that
Ma'am,
y is equal to g of x, yeah?
ma'am, here we are converting the function in terms of y, right?
Yes. So see,
Okay.
if your y is equal to g of x, okay, if we know that y is written as g of x, right? So if I take the inverse on both sides, when do I have the liberty to take the inverse on both sides? And I know that my function is monotonic and differentiable, right? Then it's invertible. That's one of the theorem. That's why we can take the inverse here. And if y is equal to g of x, you take inverse on both sides, then what will you get? G inverse of y is equal to x. So may I write? So is it fine to if I write uh, g inverse of y in place of x? So yeah, it's
Yes.
completely right. Okay. So in the theorem, we also noted that our function should be differentiable. Why? Because we are differentiating here, right? So for the function y is equal to what I took, 5x square plus 1, right? Or what? Yeah,
Yes, ma'am.
5x square,
Same.
5x square plus 1, where I know that x is a uniform, x is
From
following
0 to
uniform
1.
distribution over 0 to 1. Then obviously I
Yes, ma'am.
know it's a PDF, right? What do I need in
Yes, ma'am.
according to this formula? First, my y should be monotonic function. So check whether this function is monotonic or not. On which interval it should be monotonic?
Ma'am, can
In
you
0 to 1.
Yeah. Yes.
And
once
it
again
is
explain
monotonic
what
in
is
that range.
monotonic?
Okay. Yeah, someone is asking some question here. Hello.
Hello, ma'am. Can you just explain what is monotonic?
Yeah. See, any function is said to be monotonic if it's once its value of function, if one started increasing, then it should not decrease. Like, let's say this
It's
kind of
should
function.
be.
Yeah.
Is it like strictly increasing or strictly decreasing?
Yeah, strictly increasing, strictly decreasing is also fine. But also step function can also be like monotonic, which are just increasing, not strictly increasing. Like, let's say this kind of functions. If I say there is one function whose graph is like this, then this is also a monotonic function, okay? But this particular
Okay, ma'am.
function is not differentiable at this point, right? Why? Can anyone explain?
Ma'am, because there is a sharp turn in that one.
Yeah, ma'am. Sharp edge.
The tangent of many directions.
Yeah, infinite tangent at this point, or sharp edge, okay? So this 5x square plus 1, how this graph will look like? So we know that this is nothing but a parabola, like, right?
Yes. Yes, ma'am.
And it's a shifted parabola. So whatever it is, in the region 0, whenever your x will lie between 0 to 1, you can just check whether this function will remain monotonic or not. So just check it. So whenever it comes to monotonic, your graph should either stay stable like this, or it has to increase or decrease. If I say y is equal to x square in the range -2 to +2, then what will be your reply in terms of monotonic? Will it be a monotonic or not?
No, ma'am. It's a
No,
parabola.
ma'am.
Why it is not
Yes, yes,
monotonic?
ma'am. Yes, ma'am.
It
It
is
is
Because
monotonic.
increasing the
first it is
direction.
decreasing, then increasing.
Okay. So see, someone was saying it is monotonic, but it's not monotonic. Why? Because I say,
It's monotonic from 0 to 2, not from
yeah,
-2.
yeah. It's monotonic if you consider -2 to 0. That is also fine. If you consider -2 to 0, in that range it is monotonic, monotonically decreasing. Okay. If I say, let's say x belonging to -2 to 0, then your y is y, which is equal to x square, right? Is monotonically decreasing. But once I consider decreasing, fine. Is it fine if I write this? Okay. But once I consider my
So,
x
ma'am,
is lying, yeah,
ma'am, it should be either increasing or decreasing, right?
yeah, either increasing or decreasing. That is also fine. If once I say it's x is belonging to -2 to 1, then what will you say?
It is not monotonic.
Yeah,
Not
is not
monotonic.
monotonic. Why it
It's
is
a
not monotonic?
combination. It's neither increasing nor decreasing. It's both.
Decreasing from -2 to 0 and increasing from 0 to 1.
Yeah. And what monotonic says is once your graph started one nature, its nature should not be changed. Like if it's decreasing, then it has to decrease. What if I, for your understanding purpose only, I'm taking another example. If your graph is like step function, you know?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So let's say the graph is like this kind of thing. Then what will you say? Is it the monotonic or not? For the
No, ma'am.
interval,
Not.
let's say my x is belonging to 1 to 2, then what will you say? Is it monotonic?
No.
Neither increasing nor decreasing.
It can be monotonic, right?
There is a jump, so it
It's a
can't be
constant function.
monotonic.
For
But
1 to
in
2,
the
it's a
interval
constant
1 to
function.
2, it's
Yeah,
constant, so
it's a
it's
constant.
monotonic.
So let's change it to 1 to 3. Then what will you say?
Monotonic.
No, ma'am.
It's not.
Absolutely
It's
not.
not.
Ma'am,
It's
but at 2, the value is 2. and not 1. So isn't there is a jump? So for 1 to 2 also there is, that is not monotonic.
See, for a function to be monotonic, it is not necessary that function has to be continuous. Monotonic, the definition
Okay,
for
yeah.
monotonic is
Yeah.
once your function starts increasing, it should not decrease. See, if the graph
Yes,
is
it
like
is
this,
monotonic, but not
then it's
differentiable.
monotonic. Yeah, it's not differentiable. Even it's not continuous at a point. So
Yes.
there is no sense of talking about differentiation at a point 2. Okay. So if the graph stays like this, then it's a monotonic, no problem. But once it started increasing, it should not be like this. If it is like after certain point, it is going like this, then over this interval to this interval, this graph is not monotonic. Okay. Why? Because
Ma'am,
yeah.
can we say in general y should always increase or y should always decrease whenever x increases?
For monotonically increasing, we say that for monotonically increasing, if x increases, then your function has to increase. If x increases, fx increases, implies it's a monotonically increasing function. Okay. This
Okay,
is the
ma'am.
definition. But what about monotonically decreasing function? Whenever your
If x increases, y decreases.
yeah, whenever your f of x decreases, it says that the function is monotonically decreasing. Okay.
Ma'am, what about the constant functions?
What about constant function? Whatever your x is, your f of x has to be constant. That's what the definition of constant function.
Yeah,
So
so
that's
we
also
won't consider
monotonic.
constant and monotonic, will they?
Yeah.
It's going to be monotonic then.
Yeah, we can say that. We can use this theorem there.
All right. Okay.
It's a
Ma'am, you said before that it can be increasing. It's not necessary that always strictly increasing. So it can be constant
so,
also, right?
yeah. So this is the definition of strictly monotonic. If I say these are the definitions of strictly monotonicity. Okay. So in mathematics, you might have learned strict monotonic and only monotonic. So whenever your x increases and f of x is like we just say it in mathematical term, it's like that for every x1 greater than x2. Okay, if your f of x1 is what should it be? Greater or equal to, we say. Okay, if it is like greater or equal to f of x2, then we say that our function is monotonically increasing. Okay, for example, which one? Anyone? Modulus x over the interval, let's say
X equal to y.
0 to 3. If I do you know modulus x function?
Yes, it's the V.
Greatest integer, step function, right? Which takes the nearest integer, nearest left integer.
F of x equal to x square in the interval 0 to infinity.
F of x is equal to what? X square.
X,
See, x square
in
x square
infinity,
when
ma'am.
taken on any particular side of the around the 0, either left or right, at that time this is the example for strictly monotonic function. Okay, but this is not strictly
Yes, ma'am.
monotonic function. Modulus for x, ceiling function, these are not strictly monotonic because they stay at particular point for a interval, right?
Yes.
Okay. So these are some examples for monotonicity whenever we say 0 to infinity or any
Minus
interval.
infinity to 0.
Yeah, negative infinity to 0. Okay, do you know any function which is monotonic throughout the R?
X cube.
X cube.
No.
X equal to y. I mean y equal to x.
Straight line.
Which
And
Yes,
is
ma'am.
this is monotonic, right? It is only changing direction, but it is going like a S curve, right? So it is strictly increasing or strictly decreasing.
just take it whether it's monotonic or not. Now, if some of you have doubt at x cube, then just check about x cube. How the graph is. Just check whether whenever you increase your x, is it increasing with the value of fx?
X cube is not.
It's not. Why
X
it
cube
is
is
not?
not monotonic
Why?
because
I
it is
think yes.
increasing
For
or
odd
decreasing.
values, it will be negative. It will go.
X cube is monotonic, right?
It's monotonic, ma'am.
Is it like that? Like something like that S kind of thing?
Yes, like this, and it comes down. So it is
Right?
like S, correct.
So what do we say? Once x increases, your f of x is increasing or not?
Increasing.
Yes, ma'am.
So
Yes,
why
ma'am.
it's not monotonic?
It is monotonic.
It is monotonic. Once, what's the direction of increasing of x? This one, right?
Yes, ma'am.
So it is, yeah. Whenever the power is odd one, your function is monotonic over whole R. Okay, that was mathematics. Let's come back to statistics. Okay. So, okay, is it clear how to check monotonic or not?
Yes, ma'am.
So if I give you the function 5x square plus 1, are you able to check whether it's a monotonic or not over the interval 0 to 1? Why I am interested in the interval 0, 1? Because this is support of x, right? What is support of
X
x?
square is monotonic in the interval 0 to 1, right?
Yes. So yeah, just tell me whether we can apply this theorem.
Yes, ma'am. We can.
First, let me first tell me, is this theorem clear to everyone who is present here?
Ma'am, I have a doubt.
Yes, ma'am.
We can find inverse only under the condition. Which condition was that?
Continuous.
Your function should be one function, and if it is monotonic and continuous, that also gives a guarantee for the inverse.
Okay, ma'am. Okay.
So whenever a monotonic function is a strictly monotonic function, at that time your function is automatically a 1 function. Strictly monotonic plus continuous.
Yes, ma'am.
That's another thing. You just think, and you can also discuss it. Okay, so if it is clear to you, just tell me, is this y, which is our g of x, where x is a uniform continuous distribution, then is y monotonic? If it is monotonic, then your next task is it differentiable? If both the condition
Yes.
of g are satisfied here, then what is the distribution? So 5x square plus 1, it's a monotonic, right? Any
Yes,
doubt
ma'am.
on that? Why it is so? Because here function is what, your x square, right? The graph will be like this plus 1. That means whenever x is 0, y is equal to 1. So yeah, so your graph will be something, let's say this kind of thing, right? A parabolic function, a parabola, right? 5x square plus 1 on the x lying between 0 to 1. So it is monotonic and differentiable. Then what's your next task? We know that x is a random variable which is uniform over 0 to 1. So we also know one more thing. What is our PDF? Yes, what will be the PDF?
PDF is 1.
One only, right? And
Yes, ma'am.
then we need y is equal to g of x, which is monotonic, right? And also differentiable. So what's our next target? What is G inverse of Y? So yeah.
Root under 5 minus 1. Sorry,
X,
sir. Root
sorry,
under
Y minus 1.
y minus 1 upon 5. Yes, ma'am. Y minus 1 upon 5.
Y minus
Root
1
of y
upon
minus
5.
1 all divided
That
by
will
5.
be our G inverse of Y. Okay, fine. What is G derivative of Y? Yeah.
10x.
Yeah. G prime of X is what? Derivative of your G of X, right? With respect to X. So it is 5x square plus 1. So constant derivative 0 and rest of the part is 10x, right? Then what will be G derivative at G inverse of Y? It will be, yeah,
10.
10
10.
into root under 10 into root under y minus 1 upon 5.
Okay, fine.
Yes.
So what will be the distribution then? Fy of Y is what? 1 upon modulus of derivative of G at a point G inverse of Y, right? Into PDF of X at a point G inverse of Y, right? So this part is again 1 and what's your PDF then? So 10 square root of Y minus 1 by 5 into 1. Fine. So I can write it as 1 by 10 into square root 5 by Y minus 1. That is what my PDF.
Pardon, ma'am.
Yes, ma'am.
Yeah, continue.
Can you say that how we got that one? I actually missed that point.
Which, this one?
Yeah, ma'am. Yeah.
Okay. So this is what is this? Fx of G inverse of Y. This is PDF of what? Yes, it is a PDF of X, right? And what is your X? X is following a uniform distribution over the interval 0 to 1. Then what is its PDF? 1 upon B minus A, right? Here your A is
1
0
upon
and
b minus a.
yeah. Here your A is 0 and B is 1. So it is nothing but 1 upon
Okay, ma'am. Got it. Got it.
Okay. So this is what your PDF is. So just recall what was the distribution for your X? It was a uniform distribution, right? And now just look at the distribution of Y. So do you claim anything, conclude anything about this kind of things? Your X was a uniform distribution, but just observe your Y, distribution of Y. Is it uniform? So
Why
there,
cannot take the value
No,
1?
ma'am.
Y cannot?
Why cannot take the value 1, right?
See, this is PDF. If you go to check CDF, it will take 1 also. But we are saying, observing that X was a see, whenever we say X is following uniform distribution over 0, 1, this is somewhat standard distribution, right? Uniform, normal,
Ma'am,
exponential, this kind. Yeah.
here the range of y changes, right?
Yeah. What will be the range of Y? That is also a good question. Yeah. If it is 5x square plus 1, what will be the range?
2
It's
to
a
infinity.
continuous function, right? Yeah.
2 to infinity. Ma'am.
Is it?
1 to 6, right?
1 to 6 only. 1 to 6. Why? See,
X can be
if you
taken
say
from
5x,
0 to
if
1.
you are considering this function only, then the range is whole R. But we have to consider the support of X only. Because
Yes.
the value of y is 5x square plus 1 whenever your x is lying between 0 to 1. So your y belongs to 1 to 6. Okay?
Ma'am, is it 1 is included?
1. Yeah, 1 included. Once you put x is equal to 0, your y will take value 1, right?
When y becomes 0, I mean, when y becomes 1, the part inside the root 5 by y minus 1, the denominator part will become 0, right?
Which one?
Undefined, ma'am.
Which one?
In the last expression of function, in terms of y, inside the root, the denominator will become 0 when y equal to 1, right?
No, it is undefined, ma'am. No?
Yeah, it's not defined. Yeah, right. So
we cannot take
So
value
yeah.
1.
Yes. Correct.
And that is why I'm 2 to infinity intersection 1, 6.
Sorry, what? 2 to infinity?
Here we can take the range of 2 to y infinity.
Mm-hmm.
And our support is 1 to 6. So intersection of that will be the range of y.
But why are you taking 2 to infinity? That I'm not getting it. Can't
Actually,
we
it is
say it
saying-
as y belonging to open interval 1 to 6? Isn't it
Yeah,
fine?
that's enough. That's
Like,
enough, ma'am.
to discard this much of point is not sensible, right? We have to avoid only one. That's it. That works.
Yes, ma'am.
Okay. So after this,
We take y is equal to 0, then it is an imaginary number. No?
if you take y is
Yes.
yeah, but y is not going to take value 0, right?
Yeah.
It's 1 to 6 only.
And even 1 also.
Okay. Yeah, what? Sorry. And?
Nothing, ma'am. It's okay.
Fine. Okay. So that's what about C. So whenever there is a continuous random variable given to you, and if we are interested in finding about the CDF or PDF of a function, then there are two ways. One way is you just go directly like manually, like this, okay? Whatever your function is, just convert it in terms of x and check what are the ranges and find the CDF or PDF accordingly. And if you know that your function of random variable for which you are interested to finding out the distribution, just check whether your function is monotonic in the given support of x and differentiable also. If both the conditions are satisfied for the given support of x, then you can use directly this theorem, which says that if your random variable is continuous random variable and function of random variable is monotonic and differentiable for the support of x, then distribution, that means PDF of that new random variable, is given by this formula. Okay, so this is a kind of direct things you can directly do this kind of thing once you are confirmed with your g of x if it is monotonic and differentiable. Okay, so after that there is next thing, it says that about expectation of a random variable which is continuous.
Ma'am, one more question.
Yeah.
I have in activity 5.1, question number first. Can you solve with the manual method, not using theorem?
Okay. Let me just check which question you told.
Ma'am, question number 1, ma'am.
Question number 1, 5.1. Activity, right?
Yes, ma'am, activity.
Okay. Just tell me, is it visible to you? Is the question visible? No.
No, ma'am, it's not visible.
Okay, just a minute. So the question he is asking is this one. Is it now? So
Yes, ma'am.
yeah. So x is a continuous random variable here with the given probability, and we have to calculate probability distribution function of y is equal to x square. So which method you want to go with?
Ma'am, manual method, ma'am, principle.
Manual method.
Yes,
But why? If it's a monotonic and differentiable, then why are you not going with the direct formula?
Ma'am, but I have curiosity to how know that how solve with ma'am without the theorem, ma'am.
Without theorem. Okay. So this is what fx are. Okay. So PDF is given to you. The main thing is whenever you try with the manual method, you start with the CDF, right? So do you know the any method by which you can switch from PDF to CDF? If you know this PDF of a random variable x,
Yes, ma'am.
so can you come up with its CDF? That's the only logic if you want to go through the
Yes, ma'am.
manual. Like, yes.
Ma'am, minus infinity to 0, it becomes 0.
Mm-hmm.
Or 0 to 1, it becomes 3x square. Or greater than 1, it becomes 1.
Okay. So let's solve it quickly. X is a continuous random variable with PDF. Okay, PDF of x is given to you. Can we we are interested in fy of y, right?
Yes, ma'am.
And what's your probability y less or equal to y? So what is your y here? X square,
X square.
right? So it will be x square less or equal to y, and that is nothing but probability lying between what? Is it? Right? Is it fine for you? If I write not this one, you can directly write it as a x less or equal to square root y, right? Is it fine?
Yeah, ma'am.
That's it. Now, what will you do? This is nothing but what? Fx of square root y. So just find the CDF of x. How will you find it? If you know the PDF of x, that is what 3x square, right?
Yes, ma'am.
Then what will be 3x square for the range what?
0 to 1.
0 to 1 and 0 otherwise, right?
Yes, ma'am.
Yeah. So just tell me what is your CDF?
X cube between the range 0 to x less than, x between 0 and 1. You will integrate 3x square in the range of 0 to 1.
Exactly. So our PDF is just an integration of this 3x square. That is what? Yeah.
X cube, ma'am.
That is x cube, right?
Will we integrate over the range 0 to x, right? Fx of x.
Yes, we will integrate 0 to x only.
So here instead of x we have root y. So is that true?
Instead of x, what?
We have root y. So we will integrate from
0 to square root y. Yeah.
Yeah.
Yeah. So this will be what? Yeah, you can go like that also. That is also fine. Even if you don't want to calculate like this, you can go your x probability that x is less or equal to square root y. You can apply this thing also, that what he said, x 0 to square root y, fx of x dx, right? And what is your fx here? 0 to square root y, 3x square. dx. So that's it. That will again come to x cube by 3. That is nothing but x cube, right? Integral 0 to square root y. Is it?
Yes, ma'am.
Okay. Then what we will get y square root
Y
y.
raised
into root 5.
3 by 2.
Sorry, what 3 by 2?
Y to the power
Yeah,
3
y
by
raised
2.
to the power 3 by 2. Yes. Okay. So this is what? This is not our answer, right? This is CDF of a function. We are interested in finding the PDF of function. How will we
Differentiate.
find it? Differentiating it. Yeah.
Differentiate this.
So differentiate with respect to y raised to the power 3 by 2. Is it fine if I write like that?
Yes, ma'am.
Okay.
Okay, ma'am.
So that's all. Just integrate it. It is nothing but 3 by 2 y raised to the power 3 by 2 minus 1. What it is?
1 by 2.
Yeah, 1 by 2.
2
So
into root
square
y.
root y. Okay.
Yes, ma'am.
So yeah.
I got same answer from the using formula.
Yeah, using formula also you will get the same answer. But see.
But
yeah.
There were sort method.
Here we have.
Here we have long, but
Yeah.
formula,
So obviously
the method will become short.
the theorems are made to life easy.
Yeah. Ma'am, we go to PDF to CDF, we have to integrate the function, right?
PDF to CDF, yes.
PDF. Or when we go to CDF to PDF, we have to differentiate that function.
Yes.
Yes.
Yeah. I don't know about that.
Sorry. Okay. Yeah.
Before I don't know about that.
CDF to PDF, how will you go? Your CDF is what? Differentiation of your PDF. Any one way you remember, that's fine.
Yes, ma'am.
Okay. So CDF is what? Differentiation of PDF. They are anti-derivatives of each other. So yeah. So obviously, if you want
it's
to
reverse, I think it's reverse. PDF is a differentiation of CDF, right?
Yeah. Sorry.
CDF to PDF.
Just change it. Okay. Just tell me one thing. Very easy method to learn it. Okay. You have CDF. Okay. Let's say you have CDF. What is CDF? It's nothing but the probability. It's a cumulative probability, right? It takes it add all the probabilities. And what is similar to addition? Integration, right? So if you have your CDF and you want to calculate your PDF, that is, you want to go from CDF to PDF. Okay, you have your Fy of y, and now you are interested in what is your CDF. Then what will you do? This is addition of all the probabilities, and now you want to
integration.
So your PDF is what? Differentiation of your CDF. Okay.
Yes, ma'am.
Why it is so? Because this is the large quantity. You want to scale it down, so you will differentiate it. Okay. So anyway, you can learn it. This is what you are getting PDF from CDF. So this is CDF to PDF if I write it. Right? You are going from CDF to PDF. Now, if you know the Fy of y, that is PDF, you know that something is your PDF. That is what probability that your y is lying from some point A to B. And you want to calculate CDF, then you will integrate it, right? Will be integration of your Fy of, CDF, PDF, probability density function. And what will be the integration then? Limits?
A to B.
Will it be A to B? No. Whenever it comes to CDF, your integral limits will be support. always remember it should be support. Okay, it may not
Ma'am,
be like fixed. Yeah.
the range is from A to Y, right? A to Y. Is that
Yeah.
true?
No, because I have not defined that my lower limit is A. It might be 0. So
Okay,
that's why I just wrote it support, but you can generalize it from lower limit to your random variable y. Okay, fine. So should we move to next one? Is it clear, this integration and differentiation things?
Clear, ma'am. Clear.
Okay.
Yes, ma'am.
So your next topic is expectation of a random variable. So just remember, you have done discrete random variable, right? So if your x is a discrete random variable, how do you use to calculate your expectation of the function in random variable? You used to sum up all the,
Probability.
yeah,
X into P of X, summation over X into P of X.
yeah. But now your x is a continuous random variable. In that case,
We will integrate.
yeah, it's just similar things. So whenever you are in
In
discrete
that
random
case, we will
variable,
integrate.
yeah. So your expectation of x will be, yeah, integration for x to, yeah,
X
X into F of
into
X.
function
dx.
CDF or PDF?
PDF.
PDF, ma'am.
PDF.
PDF.
F of
PDF.
x dot dx from minus
Yeah.
infinity to infinity.
Yeah, minus infinity to infinity, or you say support of x.
Yes.
Okay. So this is way how we calculate expectation. But let's say now you have a x, a continuous random variable, and there is a function of x, let's say g of x. Okay, and then how will you calculate expectation of g of x? Is
G
there
of
any way?
x into, yes, ma'am. G of x into fx of x dx from 0 minus infinity to infinity. We will integrate.
Yeah, integration from minus infinity to infinity g of x
Support
fx of
of
x.
x.
So
Exactly.
yeah, so yeah, we can say it as a support of x. Fine. So this is how we find the expectation of g of x. So do you want any example based on that? Let's say an example. Okay.
Example means what, ma'am? Instead of G of X, what can we use? Is that?
Yeah, just I'm just writing it. Let's say you have a function.
Ma'am, are you writing now?
Yeah.
But you have
Just the question is, just a minute. X is one of the continuous random variable where PDF of x is given as 3x plus 1 divided by 3. Okay, keep it to no problem. Whenever your x is ranging between 0 to 1 and 0 otherwise, then find the expectation of y where your y is equal to x cube. Can we have anything that can solve this? Just take it.
Ma'am,
If you
first
have a
we have to.
if you have a continuous random variable whose PDF is given to you, and one of the random variable which is function of x, then can you find the expectation of y?
ma'am 7 upon 12.
Yes, ma'am.
Okay, just calculate it.
Expected value would be same as of E of X, right?
Is it so? Just take it. Is it same or not?
No, ma'am. No, ma'am. No, ma'am.
PDF is valid.
Okay. Let me check.
Ma'am, 5 by 12. Ma'am.
5 by 12. Okay.
Yeah.
Yes, ma'am.
Okay. Someone asked about the PDF is valid or not. How to check it? Anyone?
Integrated in
Integrate
range.
Integrate in the
over
range 0 to 1, right?
It should be
equal to 1.
Equal to 1 or not.
Is it equal to 1 here?
No, ma'am. 3 by 2.
I
It's
did not
not?
check it, ma'am.
Oh, okay, okay.
Yes, ma'am. It is 5 by 12.
So it's x plus 1 by 2 and what? No, it's 1 only. It's a valid PDF. Why are you saying that?
It's ma'am 5 upon 12 will the answer for this.
Yeah.
It is 5
So
by 12, right?
to check whether it's a valid PDF, yeah, it's correct, 5 by 12. To check whether your PDF is valid or not, what we do is we integrate over the support of x, that is 0 to 1 here, to fx of x dx, and that should be equal to 1, right? So let's just integrate it to clarify the confusion. So fx of x is what? Twice x plus 1 divided by 2, right? Dx. So that is what? 0 to 1, you can write it as a x plus 1 by 2 dx, right? Now just integrate it. What are you getting for integration of x is what? X
X
square
square
by,
upon 2
and what about 1
plus
by 2?
half
To
into
x
x from range of 0
for
to
0 to 1. So once you put
Yes,
the values 1 by 2 plus 1 by 2 minus 0,
half
right? It's a 1
plus
only.
yes, ma'am.
Yeah,
Yes,
it's a
ma'am.
valid PDF. So now what about expectation of y? So this is nothing but integral over 0 to y, 0 to 1, y into fx of x dx, right?
Yes, ma'am.
Because
ma'am.
y is a continuous. So yeah, 0 to 1, what is y? X square, right? And
Yes,
here
ma'am.
it's
X
x
square into
plus 1 by
2x plus 1
2.
upon 2.
Yeah, twice
And
x.
2x, yes, ma'am.
Yeah. So once you integrate, it's a x cube, right? That means x power 4 by 4 plus what will be x square by 2. That means x cube by 3 into 2. Is it fine?
Yes, ma'am. Yes,
0
ma'am.
to 1. So it's nothing but 1 by 4 plus 1 by 6. So what is? Yeah, 5 by 12. So yeah, this one was expectation of y. So here it was just a calculation part, so I did it fast as there is some concepts to discuss. Okay, is it fine with integration? Should I move further?
Yes, ma'am.
Okay.
Okay, ma'am.
So there is one more concept about joint distribution. So what do you mean by joint distribution when we say?
Is it same like in the case of discrete variables we discussed before?
Yeah, more or less.
Joint is equal to marginal into continuous. Sorry, conditional.
Sorry, what? Joint distribution is equal to marginal into?
Conditional.
Sorry? Conditional, yeah. Okay, fine. Yeah, that was the generalized formula for it. But when it comes to check what is joint distribution, then what do you mean by it? So let's say there is some experiment on which two random variables x and y are defined, where I'm saying that x is a discrete random variable and y is continuous random variable. Okay. If this kind of situation is given to you and we are interested in finding out what will be the probability that probability of x and y taking some particular value, then how to proceed, that we will going to learn. Okay, is it possible, first let me just tell me, is it possible that you are defining two random variable, one is discrete and one is continuous, and now you are defining joint distribution? Is it possible?
Yes, ma'am.
Yes, of course it is possible. The thing is, we will have some liberties due to this discreteness of x. So just check how we use it. Okay. So x is discrete random variable. That means there will be PMFs, right? Px of x. And here, what will we have for continuous? PDFs,
PDFs.
right? Now, sometimes we will be given situations where the probabilities, or we say it as a, just say probability, okay? Probabilities of y given x taking some value x. That means probability of continuous random variable given that x is happened already. This kind of probabilities are given to you. That means, can we say it probability of continuous given discrete random variable, right? This kind of things are given to us. Then we use this information to find out conditional probabilities and all these things. So how to find it? Okay. So yeah, in this case, what will be the marginal density of y? Marginal density of y. Do you understand what is marginal density? And when this marginal terms comes, see, whenever there are two random variables, at that
Y
time,
remains constant, right, ma'am?
yeah,
Summation over y remains constant and x value changes.
yeah, exactly. So whenever this kind of stuff is there, there are two random variable defined on an experiment, then you cannot find the PDFs like this directly as we used to, like what is the probability that x is taking this particular value, because now it's a joint density, joint distribution. That means the probability that x taking particular value is also depends on the what y are taking, right? So in that cases, we come up to terms like marginal density of y. How do I define it? Representation will be look like this. But how we will calculate marginal density now? So
It's a mention.
yeah, so our x is a discrete random variable, right? So it will have some what we say, finite values. That means, let's say range of x is some tx. So range of x is finite. So I will sum up all the probabilities or the mass functions of x and multiply it with what? Yeah, any idea? I will multiply it with the conditional probability that y taking value y and x has already taken value x. Okay. So just remember, you can just remember we have learned joint distribution of x and y when both are discrete random variable, right? If both are discrete random variable, then how we used to find the marginal density of let's say x or y, let's say y, okay? How do you
Ma'am,
use we use
constant like we
Joint divided by conditional.
yeah, what?
Joint divided by conditional.
Joint divided by conditional, yeah, that is also fine. Divided or multiply? Marginal. How do you use to calculate the marginal? See, we used to have this kind of tables, right? So we used to calculate fx of
summation over y, ma'am, with a constant x, ma'am.
Keeping y
Do you
constant.
remember this kind of, yeah, keeping y constant and adding all the joint PDFs of x, right?
Yes.
So in that case, this was not there. Yeah. Okay. So similar thing we are doing here, just differences. Why we are using conditional here? So if you what we say, write this explicitly, you will find something. How do you write conditional? What is the formula for conditional? If I want to calculate x is equal to x, okay, at that time, how will you calculate this this thing, like this probability? Like I want to calculate conditional probability of y given x is taking value x. How will you calculate it? So just apply the formula for conditional probability. What is the formula for conditional? That f is taking value x is equal to x and y is equal to y, right?
Yes, ma'am.
Isn't it? We write it like a joint, right?
Yeah.
Because this is a joint distribution here. Divided by what?
Probability of
Fx
F
of
of
x.
x equal to x.
yeah.
So
F
just
of x.
remember in this particular case, this fx is not f, it is p. Why? Because my x is discrete random variable. So can I write it as a px? What I have written here?
Sure, ma'am.
Px of x multiplied by this one. So once I multiplied it with the px of x, this px will get cancelled and what will remain? Only joint PDF, right?
Yes.
What was here? The same thing. Are you getting me? So things are same, but due to continuous nature of the random variable, some like notation will get changed. So this is one of the way how to remember this kind of stuff, that what to multiply after this px of x. Okay, so try to understand concept instead of learning the formulas. Okay, so if I give you some question, I think that will be better to understand this kind of stuffs. Is it is it okay if I move ahead with the question example?
Yes, ma'am.
Your
Yeah.
x is a continuous, x is a discrete random variable, y is a continuous random variable. Okay, so now we are interested in finding the marginal density of y. Let's say my x is following some binomial distribution with probability 1 by 2, and one more thing I have given there, y given x is equal to 0 is following normal distribution with mean 0 and variance 1. Y given x is equal to 1 is following distribution normal 1 comma 1, and y given x is equal to 2 is taking n 0 comma 4. Okay, that is normal distribution with mean 0 and variance 4. So if I want to calculate my marginal density for y, then how will you try it? Fy of y. So do you understand? X is a random variable, which is binomial distribution. N is 2 and probability is 1 by 2. So is this much information enough to calculate marginal density of y?
Yes, ma'am.
Okay. So just try it if you are able to solve it or not.
Ma'am, sorry for asking. y given x equal to 0, that symbol notation, similar notation, and to the n01. What does it mean actually?
Okay.
Can you?
Yeah, this one, what does it mean, right? Okay. So just tell me what this notation means. X is following.
X is following a binomial distribution.
Right? Where
Yeah.
your n is, this is value of n, this is value of p, right? The similar thing is here. Y given x is equal to. So x is your one of random variable. Y is also a random variable, right? Continuous random variable. So what is y given x is equal to 0? X is a random variable, y is a random variable. Y given x is equal to 0. This is what? Whenever you think about this kind of situation, what do you think about this? These are all the events where values of y are varying, but x is fixed, right?
Yes, x
So,
is fixed to 0.
so generally, our joint PDF, we represent it like fxy, right?
Yes.
Isn't it? So whenever this kind of
Yes,
situation is there, what is fixed here?
x0.
X equal to 0.
Y, but y is taking value y. But this is what? These are all the possibility. These are all the events where x is taking value y 0 and y is taking value any value y, right? But
Okay, ma'am.
whenever y given x is equal to 0 is given there, that means first function has taken value 0. After that, you are going to calculate what is the probability that once x has taken 0, what is the probability that y is going to take some particular value y, right?
Okay, ma'am.
So isn't it behave like a random variable? So once you have two random variable x and y, then what do you say, conditional things like y given x or x given y, these are also a random variable. So if they are a random variable, then obviously they have some distribution, right?
Yes, ma'am.
Initially we observed one thing, that if x is a distribution following, x is one of the random variable which is following uniform distribution, that doesn't imply that y is equal to g of x is also uniform, right?
Yes.
We clarified with one example, that 5x square plus 1. So if x is discrete, y is continuous, then y given x may follow any distribution, right? It depends on how they are distributed. See, here in this particular question, x is following binomial distribution, and y given x at 0 is following normal distribution with mean 0 and variance 1. Okay, so basically your question was, is it clear that y given x is also a random variable? So this random variable is following this distribution, normal distribution.
Because
Okay.
y is continuous, right?
Yes, because of the y.
A normal
And
distribution
this mean and variance.
comes into play whenever the function is continuous, right?
Sorry, what's your question?
We discussing. I mean, we have discussed many distributions, and most of all them are related to continuous, right?
Yeah.
So y is here continuous and x is discrete. Then we can say that in general we can say that y given x must be continuous. Is that true?
Yeah, most probably, but we can't claim.
Why we are? I mean, the normal distribution with the 0, 1. This 0 and 1, how it connects with the
Yeah.
y given x equal to 0.
Yeah, that comes that is because this x has taken value. Like I told you, no, whenever y given x is equal to 0, that means you whenever event or experiment was happened for this particular thing, at that time there was a condition that x has already taken value 0. Now you calculate, now you find the distribution of y. That means there was a restriction on x variable, that x has already taken value 0. Now find what the distribution y will follow. Accordingly, we calculate things and like this only. Yeah, this one. Where we have given that x is distribution, x is following uniform distribution. Now calculate what the distribution y is following, right? This was the simplest form. That's why we start from here. So this was the simplest form, that x is following uniform. Now find the distribution of y. So there was this method. The similar thing happens here in the joint kind of things, where we say that x has taken value 0 and y is some continuous random variable. X is following binomial distribution. Now calculate the distribution when x takes value 0, what the distribution y is following. Accordingly, we define, we calculate some things and come up with the final result that it's following some normal distribution with mean 0 and variance 1. Actually, when we see this conditional probabilities, conditional variables, to find this kind of distribution is, I think we learn in next to next week. That is somewhat complicated, where we have to
Ma'am,
fix
how it connects with the thing that mean is 0 and variance is 1? I
Yeah.
have this genuine doubt. I don't know how
Yeah.
it connects.
So whenever you find the distribution here, okay, in that from that looking at the distribution, we find we get to know that what will be the mean and what will be the variance. Even your distribution is normal or exponential or whatever it is, that will also define based on the PDF or CDF. You get to know about y given x is equal to 0. So there are some proper ways that we will discuss, I think, after quiz 2 only. So we will learn that also.
Okay, ma'am.
Okay, so fine. Have you guys calculated what is the marginal density? Anyone? What do you get? So if I give you hint, this is nothing but what Fy of y is what? Summation of all the PDFs of x into, sorry. Yeah. Fy of y is what? Summation of all distribution mass function of x multiplied by conditional, right? Over all possible values of x, that is x is equal to 0 to 2, right? How did I get this 0 to 2? Yes.
Hello, ma'am. In this equation, this Fy of y represents the joint distribution, right?
Fi of y is marginal density.
Marginal density
is the sum of all the joint joint probabilities when y is fixed and x is varying. I have explained here somewhere, right? For corresponding to this discrete. What we used to do when this joint probability fxy was given to us, right? Here x1, x2 are there, y1, y2s are there. Then whenever we used to calculate fy1, fy of y1, what do you used to do? You just add these terms, right?
Adding up all those at some y1 equal to some value.
You used to fix this y1 and vary this x1, right? And used to add these joint probabilities, isn't it? The same thing we are doing here.
This is marginal, right?
Yeah, this is marginal. The same thing we are doing here. This is marginal, right? Same thing we are doing here.
Okay, ma'am. Yes.
This is also a marginal. So, yeah. Further, I think you can do it onward this. Once I write px of 0. where x is following binomial distribution with probability 1/2. Will you able to do this? Find out this px of 0? Fy given x is equal to 0 at a point y. Yeah. This one, will you able to find out what this will take? Because we know that y given x is equal to 0 is following what? Normal distribution, right? With mean 0, variance 1, we have a formula for that. Hello, is it fine for you?
Yes, ma'am.
So, yeah, what is the probability that x is taking value 0?
1/3, ma'am.
1/3 or what? How did you come with the 1/3?
Because x is a uniform distribution 0 to 2, ma'am. No?
Just a minute. X is not uniform, right?
Sorry, sir.
X is a binomial distribution from 2 to 1/2. Sorry, n is 2 and probability is 1/2. So you have to use the formula for binomial random variable.
Ma'am, it's 2C1 into 1/4.
Sorry?
It's 2C1 into 1/4. No, ma'am, 2C0 into 1/4.
Into 1/4.
Yes.
How did you came up with the 1/4? 2, right?
Yes.
Okay. And what is this? Y given x is equal to 0 is following normal distribution with mean 0 and variance 1. So
1/√2 pi into
square root 2 pi into exponential to the power minus y square by 2, right?
yes.
Okay. What is px of 1? So it's a 2c1 1/2 square again. Right? Fy, okay. Now y given x is equal to 1. This is following which normal distribution with mean 1 and variance also 1. Then the formula is 1 upon square root 2 pi into variance, that is 1. And e to the power what? Minus
1 minus y the whole square.
y minus 1 the
1 minus
square.
y.
Okay, it's a square, so you can write both.
Okay.
No problem. Okay, 1 minus y the whole square by 2 plus then 2c2, right? Px
Yes,
of
ma'am.
2, that means 2c2 1/2 square, again the same thing, 1 by square root 2 pi. Variance is what?
2.
4.
So
Yeah.
it will come
So it will be 2. Yeah. So standard deviation is 2 and e to the power, your mean is 0 here. So minus y square by 2. So yeah, that's what we simplify it and that's what the solution was. Okay. So this was all about marginal density. Yeah.
And are we doing week 6 in the another session?
I thought to cover in this session only, but it seems it's not possible.
Yes, ma'am, because it's already 7:40.
Yeah. Do you guys have any lecture after this?
Yes, ma'am, Python session.
Okay. At what time? 8 o'clock?
Yes, ma'am.
Oh, okay, fine. So we will sum up with this week 5 only. Okay.
Thank you so much, ma'am.
Yeah. After this, yeah, what?
Revision is necessary, ma'am.
Yeah.
This one is my first session, and I felt it's very helpful. Thank you so much.
Yeah, thanks. So I think this was all about week 5, right? After this, joint density is there, and for that, so we can continue till 8 if you guys so.
Yes,
if you
ma'am.
guys are okay.
Yeah.
Yes.
Okay.
And how do we plan to do
Yeah,
week
sure.
6, ma'am?
Sorry, how do you?
How do we plan to do week 6, cover week 6?
Okay, for that I have to discuss with the team and we'll let you know.
Okay, ma'am. Thank you.
We will update on your on the calendar. So, okay, fine. So this was all about marginal density. Now, what if we have the knowledge of the marginal density and want to calculate joint density? Then it's possible, right? Sometimes we are given with the marginal density, right? And asking about the joint density. So again, and now we are
Ma'am,
dealing with the, yes.
how does this name came density after joint and marginal density, joint density?
How this what?
The word density came after joint, like marginal after density.
I didn't understand your question. What are you asking?
Ma'am, I am not aware of that joint density. This term, the term, how did came?
Okay, how, like, from where this concept came? Are you asking
No, ma'am.
about
The
this?
density word density after joint, how it added? Is it because of we are discussing PDF?
Yeah, so what is the full form of PDF, by the way?
Probability density function.
Probability density function, right? What does it mean? Like, okay, we know the meanings, right? What do you get feel when you talk about PDF? What do you think about it?
The
See, whenever we say it's a continuous
values
random
are
variable.
dense. I mean, they are dense. Some.
Yes.
So we have to integrate. We don't have to. We couldn't count each by one, each one. So we have to integrate, sum it up.
See, probability density function, that means this is what we say it as a fx of x, right? This is our notation. What it calculates the probability that your random variable x is going to take values lying between some, let's say, some point a to some point b. Okay, so this is the probability that your random variable is taking values between a and b. That's what probability density function. Why it's density? So a and b. So once your x is continuous random variable, so obviously there will be uncountable points lying between a to b, right? So let's say this is somewhere a, this is b, this is a real line, and now you want to calculate probability that x is lying between this one. Okay, so how will you go with that?
We have to integrate, right?
Yeah, that's how we integrate. Okay, what someone is asking. Okay, so 17th is your deadline for
Adding
what?
up all the small segments, dx's.
Yes, 17th is the deadline, ma'am.
For this assignments, right?
Yeah, week 5 and 6 mock is deadline is 17th.
Deadline is 17th, Sunday. Okay, fine. So is it possible that in morning session can we have morning session for on Sunday?
Yeah, sure, ma'am.
Okay, so on discourse we can discuss the time and okay, yes, Vivek Kumar.
Yes, ma'am. I have a doubt in lecture, ma'am.
Okay.
In
Okay,
additional content.
Okay, just a minute. So
Okay.
yeah, this was a probability density where you integrate. Okay, this was density functions. Now you
Got it,
now
ma'am. Got it.
come to the joint density.
Ma'am, can we take the questions after the you're finished with week 5? At least we can plan on finishing week 5, right?
Yeah, sure. So joint density. So let's say your x is a random variable which is continuous. Now y is also continuous. And now, so obviously when there are two random variable, let's say x and y, so when x was a single random variable which was continuous, at that time this there was only one interval, right? The probability that random variable is taking values in this interval. Now what if your x and y both are continuous random variable and we are interested in finding the probability fxy taking value x and y? So obviously this is somewhat the probability that x is lying between some interval, y is lying in some interval. So it will be what? Will it be interval or what? Will be a surface like this.
So there
Right?
will be double integration.
Yeah,
Right.
exactly.
Area. Okay.
And from there on, and the topics onward that is covered in week 6. So now as time is not permitting to us, so we can move to the questions of week 5. So first, yeah, someone was asking some doubt. So let's take it.
Yes, ma'am.
Okay, yeah.
I mean, additional content, ma'am. Week 7, ma'am.
Week 7. Let's complete week 5 first. On week 7, we will have the revision session. There will be a dedicated revision session on week 7 and week 8. But as like today's session was dedicated to week 5 and week 6, so I will try to stick on the week 5 and week 7.
Okay, sorry, ma'am.
So is there any doubt from week 5? So we can go ahead as time is not permitting for week 6.
Okay.
Yeah. So which question you were asking? Is there any questions?
No, ma'am.
No, ma'am.
Okay, then we can continue with the week 7 additional content.
Okay.
Yeah. So what's that topic is?
Concentration phenomenon, ma'am.
Okay. So I think
What, ma'am?
statistics, sample variation, sample and all, right?
Yes, ma'am.
Yeah. So just let me check week 8 open session has done or not. It's not, yeah? Is it? So whoever take the week 8 open session, they will start from that part only.
No, ma'am. No, and there is a wicked operation happened.
No, it's not, right? It's on coming Tuesday, it seems.
Yes, ma'am.
Yeah, Sunday. Okay. So I think that part will be covered there. So as you have class from the 8 p.m. onwards. If there is any doubt related to this part, please ask. Otherwise, we will stop here.
Ma'am, for week 5, what are the main type of questions we can expect on quiz 2? Like, what are the main things that we need to be clear about in while solving our questions, and what major type of questions that we can expect to see?
The level, whatever we discussed today, yeah, that kind of things will be there. That's it. The level will be more or less up or down about that in the neighborhood. Yeah.
Ma'am, from week 5, there is also questions from variance.
Yes.
I get that questions.
See,
But the formula are same from the previous weeks. First we calculate the expectation of x, then
Yes.
expectation of x square.
For example,
and
today we discussed
will
this
find
expectation of x, right? If I
Yes,
ask
ma'am.
the same question, like for example, this expectation of x is recently we calculated, right? If I ask the same question, that the same thing, whatever the things are, this one, right? X is a continuous random variable having PDF this one. Then if I add one more question that calculate variance of y, is it possible to calculate variance of y with this much information? Yes, right? Because
Yes,
what will be
ma'am.
the variance of y? Expectation of y, that formula, right?
E of y square minus E of
E of
y
y the
whole
whole
square.
square. So E of y you are calculating. Now the task is to calculate E of y square. What is y? E of y square? Sorry, y square is x power 4, right? The similar thing, the same concept will be there. Instead of, if you can calculate expectation, that means you can calculate variance also, right?
Just the equation will change while
Yeah,
calculating.
obviously. The integration and integrand are going to change. That's it. That are the only changes. The rest of the part will be the same. So these are the what basic concept on which you can expect the question. So obviously there are some variance kind of questions, some, and the same question in the language form we can ask there, that similar. For example, this one, we can say that, okay, like x is some random variable. For example, if I say you,
Ma'am, this equation came from the concept JD equal to marginal into condition, right? This
yes,
equation.
marginal into
Okay.
condition.
From that equation, we got this, right? Fy of y equal to this one.
Yeah, just check
Ma'am, I
whether
will go through this. I will try to understand this. If I have doubt, I will ask you in the next session.
yeah, sure. Whenever there are joint density kind of things, just check whether your both the random variables are continuous or one of them is discrete. If one of them is discrete, then you have to go with this joint probabilities. If both are continuous, then try to check whether they are independent or not, because that will help you when both the random variables are continuous. So
Okay,
like,
okay, ma'am.
okay. So any doubt, any activity questions or anything? So actually, whatever we discussed today, these are the basic stuffs. These are the, what we say, are the pillars for week 5 content. Whatever you will see in the question paper are more or less connected to these concepts only. You will, if you got to know that how to use this kind of stuffs using whatever the information given in your questions, you will definitely reach to your answer, because these are the pillar concept. Yeah,
Basics should be strong, right?
yeah,
Then only we can build answers anytime, anywhere. If we are very strong at basics.
yeah. Because rest of the part is integration only. Just check what is needed, like PDF or CDF. And one thing I told you before also, if you know about the distribution, that know about the distribution means either you know the probability density function or you know the CDF of the cumulative distribution function, you can get to know each and everything about that random variable, either CDF or PDF. Because today only we learned, like again revise that how to go CDF to PDF, PDF to CDF, right? Yes. Any other question?
Yes, ma'am.
And can you just scroll up and go to the very first question you started?
Yeah. Yes. This was the first question we started with.
Yeah, ma'am. There, the x is uniform from 0 to 1. So
Yes.
the support is from 0 to 1. If you change the support from -3 to 1, then can you just tell me the steps or the procedure to find the CDF of and PDF of x, not z or y, but simply just of x?
Yeah. That means you are saying X is following uniform distribution from what?
-3 to 1.
-3 to 1. And
Yeah.
what is your G of X? Y or Z? What do you want?
Y will be x square.
Okay, y is your x square. Okay. So, what will be your first task? Just find what is your CDF for this uniform distribution function, right?
Yes, ma'am.
Okay, let me just write all these things on the fresh page only. Minus 3 to 1, y is equal to x square. Okay. So, yeah, x is what? Uniform distribution over minus 3 to 1, and y is equal to x square. We are interested in finding CDF or PDF. What do you want? Anything. Let's say CDF.
Yeah,
Okay.
ma'am.
CDF of y. So, yeah. So, first task is to always find whatever you have. That is distribution of x, you know. So, we can have fx of x, right? That is the
Yes, ma'am.
easiest step we can do. Fx of x is what? X minus a by b minus a, right? Sorry, x minus
Yes.
b by b minus a. That
Yeah,
means
yeah.
x minus 1 by 4, right?
Yes, ma'am.
Whenever your is it 0 to 1 and 1 elsewhere, right? Right? This is
Ma'am,
your
how did you put the equality sign on minus 3 to x and not from x to 1? I mean, I'm just a bit confused on the equality signs that have been put. That is
okay.
the area where I'm getting confused.
Okay, see, whenever minus 3 to 1 is there, the best way is to plot on the real line, okay? Minus 3, let's say 0 somewhere here, 1 somewhere here, right? This is your real line. Now, what is CDF? CDF is the cumulative density function. That means it will add all the previous probabilities, right? Now, till minus 3, do you have any event? No.
No, ma'am.
So obviously the CDF will be 0. There is nothing to add here. Now, from minus 3 to 1, there is event, right? That is what? Uniform distribution. So
Yes, ma'am.
from minus 3 to 1, whenever you will, your range is between this, CDF will be followed as you know the formula for uniform distribution, right? That I wrote for the minus 3 to 1. Once you reach
Yes.
to 1, that's all. Once you reach to 1, you will add all the previous probabilities and that will sum up to 1. Why? Because it's the sum of all the event. It will exhaust your experiment, right? Exhaust all the events and it will sum up to 1, right?
Okay, okay.
So
Understood.
after 1, your CDF will be always 1. Okay. So
Ma'am,
why? Yeah.
any reason for including minus 3 and excluding 1?
Including minus. Just
Yes,
to
in the range, ma'am. Middle one. X minus
this
1
one.
by 4.
Okay.
Yes.
Not so. You can write this like this also. X less or equal to minus 3 and like this.
Okay. Because it is continuous, so we can write anything.
Yeah. Because we know we have learned one thing. If your distribution is continuous at a single point, probability is 0, right?
0.
So that's why you can just don't skip any point and don't repeat any point. That's the rule.
Oh, okay. Then
Okay.
that will be fine. Okay.
Yeah. So either you can have this thing also, x less than minus 3, less or equal to minus 3, equal to, and here x greater than 1. Okay. The main concept is don't leave any point and don't repeat any point.
Repeat
Okay.
them. Oh.
Fine. So we are interested in finding the CDF of y. Y is equal to x square. X is minus 3 to 1. Okay. So what will be the range of y here?
Ma'am, the formula for finding the CDF is x minus b by a minus b, right?
Yeah.
Okay, ma'am. Okay.
X minus b by b minus a. What is range of y if y is equal to x square and x is what uniform over minus 3 to 1?
0 to
Be 0 to 9.
0 to 9. But just remember one thing. When it's taking 9, when it's taking 0. So here, because in this particular function, there will be break at one point. whenever your range is 0 to 1, your x is belonging to 0 to 1. What are your y will belong to? Again 0 to 1, right? Whenever
Yes,
x
ma'am.
belongs to your -3 to 0, right? At that time, your y will belong to what? 0 to 9, right? Isn't it?
Yes, ma'am. Yes.
So let's just calculate CDF of Fy of y. What is it? Probability y less or equal to y, right? And y is nothing but x square less or equal to y. So I can once again, I will rearrange it because here also 0 to 1 is here, right? So I will just rearrange one thing here. -1 to 1. Okay, whenever your x is -1 to 1, y will be 0 to 1. Is it fine? Just
Yes,
take
ma'am.
it. Okay. Whenever I start with the -3, I do not, if it is 0 also, it's 0 to 9. It's not symmetric in that case. So what I will do, I will just break it. How? See. So whenever x square is less or equal to y, that means probability x less or equal to square root y. Fine. Now I want, I'm just checking for -1 to 1. X is ranging between -1 to 1. So x square less or equal to y, that means how do I, how should I write it? Any idea? May I write it as a minus y to plus y, or minus square root y to plus square root of y? Because if x square is equal to y, let's say, just a minute, I will give you example with the numbers. X is equal to, x square is equal to 4. What are the values of x?
That's -2.
Right? So may I write it as a minus square
Ma'am,
root
but
y?
here
Mhm.
we can take the minimum value for x is 0, right?
Yeah.
So
But
it should. So it
yeah,
is from 0 to root y.
0 to root y. Okay, fine. No problem. You can integrate like that. But when I will find the probabilities from -3 to, let's say 1, -3 to -1 or 1, at that time this part will not get covered, no? Or you can try it. No problem.
Okay.
But the thing is, as in our domain, -1 is included. So I do not want to exclude it. This same thing I am using it -y to y. If the where support was given from like 0 to 1, kind of, it was given
Ma'am,
there
can
0 to
you
3.
can you
What?
Ma'am, can you explain it again? -1 to 1. How do we get that? X
This
lies
one?
between minus
This
1 to
one?
1. You said. Okay. It's already given, right?
Y is equal
Uh,
to x square, right? No, it was not given. I have find out it. Y is equal to x square. So
okay.
if you, even though if you put -1 or -1/2,
-1
the
to
y
1.
will lie between 0 to 1, right? That's why I have to integrate like that. So yeah, what will be the integration? Minus square root y to square root
Okay,
y
got it, ma'am.
and fx of x dx. So what is fx of x? Okay, you are the only one who asked the question.
Yes, ma'am. X square.
Yeah. Square root y to y. What was it? X minus 1/4. So just integrate it. What are you getting here? Yeah. Nothing but x square by 2 4 8 minus, let me just write it like Let's take 1 by 4 common, x square by 2 minus x by x, okay, minus square root y2 plus square root y. Okay, so yeah, minus square root y plus square root y will get cancelled, right? 1 by 4, it will be y by 2 minus square root y minus again y by 2 plus, sorry, minus plus, yeah, again it will be, is it x minus 1 by 4? Yes. Y by 2.
Finally, we will get
Twice root y by 4, right?
Yes, ma'am. It will
root
be twice
y
root
by
It will
2.
be, yeah, twice root y by.
That's
So,
plus root y, right? Oh, okay, okay,
yeah,
okay.
yeah.
Got it.
So this is what, twice root y by 4, but when y is ranging between 0 to 1. Now just tell me, now can you just tell me why I took integration from minus square root y to plus square root y? Anyone can give the valid reason for it? Because my
Ma'am,
task is
actually,
to calculate for y ranging between 0 to 1. So I need all, I have to calculate the CDF for all the x's whenever the values y can take 0 to 1. So the function was x square, right? So once I draw the function x square, let's say 0 here and somewhere 1 here, right?
y can be 1 whenever x takes minus 1 and 1.
Yeah,
Minus 1
that's why
x.
I cannot skip. I should not integrate from 0 to square root y. Instead, I have to integrate from minus square root y to y, right?
Ma'am,
Because my
ma'am, is that the reason? Hello?
yes, the recent question only we
Ma'am,
are discussing.
ma'am, is that the reason you took x from range to minus 1 to 1? Is that the reason?
Sorry, x can. Yeah. Yes.
You took
That
x
was
from minus 1 to 1
yeah.
because when y equals 1, x can
Hmm.
be minus 1, right?
Yes.
Minus 1 as well as 1. So
Hmm.
the minimum value for x is minus 1
Yeah.
from there to 1.
Yes.
So that's
Exactly.
why you took right.
Minus 1 to 1. Yeah. But just note that given it was given that x is following uniform from minus 3 to 1. If the same question was instead of minus 3, it was 0, no? 0 to 1. At that time, what I may have done, I may have
Used formula.
yeah, I have not integrated from minus square root y. Instead, I will write it from 0 to square root y. Why? Because the support of x do not include minus 1, right? Did you get my point? If my
Function
x
is
was,
here
if
the function is
function is means, function is this one, no? PDF of
Function
a,
is same. Y is equal to x square. Just the support is
oh
changed from
x
minus
square.
3 to
Okay,
1
okay,
to 0 to 1.
once support is changed, then
okay.
then no need to integrate from minus square root y to yeah, function is same, y is equal to x square. Yeah, for this only I do not need this minus square root y now. Why? Because this is not the support of my x. So even though when I will calculate probability y less or equal to small y, it is x square less or equal to y. At that time, I will not write it as a x lying between, even though it will lie
Ma'am,
at minus square root y to, just a minute. X is lying between minus square root y to plus square root y, but I will write the next step after this that I do not need this minus square root y because this is not in my given support of x. So I will integrate from 0 to square root of y. So we have to adjust our limits according to the support. The same thing we are going to do next when we will integrate from minus 3 onwards. See, here Just a minute. Yeah, our uniform x is a uniform random variable from -3 to 1. We have calculated CDF for y ranging between 0 to 1 only. But the range of y we calculated is 0
0
to
to
9.
9.
So rest of the part is we have to calculate, right? That means from, so y belongs to 0 to 1. What is your fy of y for that? We just calculated twice
Root
square
y
root
by
y.
2.
Yeah, root y by 2. Fine. Okay, this is from whenever your y is ranging between y0 to 0 to 1. What when y will range from 1 to 9, right? This is remain part, isn't it? So what will be the values of x when your y is ranging 1 to 9? Yeah, x has to belong
-3
from,
to 3.
but your x is a uniform distribution from what? -3 to 1.
So we will take -3 to 1.
Yeah, -3 to +1 or -1 is enough.
-1.
Because if you
Because
take
-1.
Yeah,
-1
continue.
to 1 is already calculated.
Is already calculated, and also one more reason, if you take -3 to 1, then your range is not 1 to 9, then your range is 0 to 9.
Okay, ma'am. Okay, good.
Okay, so -3 to -1. So
Ma'am, this y, the range of y will be given in question, right?
this ranges, no, you have to estimate it.
Okay.
You have to estimate.
So how
Actually,
can we
this
decide
question was
whether
given in the lecture, the first lecture itself of week 5, and that is
Yes.
why I got confused here in this part where the range we have to adjust. That is why I asked this question.
Okay, no problem. That I know. This is the question from lecture. So fy of y for this range we are calculating. Okay. So let's see. Probability y less or equal to y. Now this is nothing but probability x square less or equal to y, right? And one more thing, you have to take note that even though you know the upper limit and lower limit, don't put directly that limits when you are calculating for CDF. The reason behind that is, once you put the fixed limits on integration, that means you are not no more calculating CDF, it's going to calculate PDF, right? Are you getting my point? Once you fix
Yes, ma'am.
your limits there, it's not CDF anymore. It will give you the probability for that particular range where you are integrating. And what CDF is? CDF will add all the previous probabilities, right? It's a cumulative one. So let's start with this x square less or equal to y. Now, what should we do? As we have covered till 1, right? So now I want my probabilities from, even though it's, once I elaborate it, it is square root minus square root y to plus square root y, right? But I have covered this upper limit, right? Till 1. Should I replace it to 1? Is it fine? Because I know the values when it was minus square root to y for y ranging from 0 to 1. Now I am interested for the values y ranging from 1 to 9. Okay. So whenever I will find out from minus square root y to 1, I will not let this y to get to 1. I will start from the -3. Okay. So how will we integrate it? Again, the same thing, minus square root y to 1. And what is our fx of x? Dx. What was it? X minus 1 by 4, right? Dx. Again, 1 by 4 common. And yeah. X square by 2 minus 1. That means x minus square root y 2 1. minus y by 2. Minus minus will get plus, right? Again get minus. So yeah, do we add two more any terms here afterwards? Hello.
Ma'am, in front of okay, got it.
Okay, let me just. It will be like minus minus minus, and this
That's
one
true.
minus. Okay, yeah, fine. So yeah, then what will get minus 1 by 2 minus this will be plus only. So y plus square root 5 by 2, right? So that's our fi of y, but this is
2 root
for
y, right?
minus.
Y plus 2 root y, is that?
Yeah, yes. 2 square root y, yeah. So yeah.
Ma'am, somebody told that we have already calculated from -1 to 1. I don't get that actually.
Yeah, we
I
have
will
to.
ask you in the next session. I know our time is getting.
Yeah, so what happened?
I was just asking that in the question we will get an equation, right? Y equal to some expression, and the region from where
Yeah.
x starts and x ends, that also given in the question. From there we have to find this
Range of y. Yeah.
range of y.
Hmm.
Okay,
So
ma'am, got it.
yeah. So after that calculation is there, and yeah. So I think main doubt was this one only. Why sir has distinguished the both of the limits, right?
Yes, ma'am. And suppose the whole support was on a particular quadrant, like in the where the values of x will be negative only, then I don't think then at that point there we have to do such thing, because then the function will become monotonous, I guess.
Yes. If function is monotonic and differentiable, then no need to go through this kind of stuff. See, here y is equal to x square is not monotonic on this given support, right? -3 to 1, it's not monotonic. That's why
And
we are
if we
going.
change from -3 to -1, then it will become monotonous.
Then it will be monotonic. But you can't apply like that, this kind of things, okay?
Yeah.
Okay. So y is equal to x. So I'm just summarizing this question. Okay, do you want to solve this particular thing, mechanical part? Or you will just try?
No, ma'am.
Okay.
There is no problem in calculation. The
Yeah.
problem is in the
Even
concept of
calculation is given there,
breakouts.
right?
Yeah.
Okay, so fine. So I'm just revising it. See,
Understanding the
whenever
problem is important.
yeah, that's why I left it there. So see, whenever the question will be like you have given with the continuous random variable and its support is given there. Obviously, it is not mentioned in the words that this is support. You have to only understand that this -3 to 1 is support here, and random variable is given to you. So the very first task you should do is just calculate the CDF or PDF, whatever you are comfortable with, of x. Of x means a known distribution. Okay, that doesn't mean always x is given, right? Of known distribution. Once you have done that, then the next step will be the range of y. Okay, calculate or find the range of y. After the range of y according to x, okay, whatever the values. If you say y is equal to x square, then someone will say, okay, range is minus infinity to infinity. That's a valid point, but over the support, yeah.
From here, we have a y equal to x square, and x is uniform over -3 to 1.
Yeah.
So So we are putting the values for finding y. So y
Yes.
will get 1 to 9. Y will have values 1 to 9. From there, we are again looking back and taking values for x,
Yes.
which can be related to y.
Yes. Here the range of y is 0 to 9. Okay.
So here we are filtering x as a monotonic, right? Is that
No. If your range is 0 to 9, see, are you okay with like how it's 0 to 9, not 1 to 9?
yeah, got it, man, got it.
It's
It's
0 to
my
9.
mistake.
Now, if
Yeah.
you see, if you know the function, what the function is given, let for example, if it is x square, x cube kind of things, then I would suggest you to plot it. That will give you some clarity. -3 to 1. So let's say somewhere here it is -3 and somewhere here 1 and 0 here. So your graph will be somewhat like this, not this much sharp.
Ma'am, got it.
Something like this, right? So we know that this kind of function x square is symmetric function. That means from -1 to 1, whenever I will go, my values of y is equal to 1, right? So whenever I say my value for y is lying between 0 to 1, just capture what are the values for x, that is -1 to 1, but we are going to calculate CDF. So I will say it minus square root y to plus square root y, and y is 0 to 1. Okay, so it will cover my all the values of y ranging between 0 to 1. And then yeah, after calculating the range of y and this kind of limits, you just do the required stuff for CDF calculation, and that's it. And that's all about the CDF. Okay.
Okay, ma'am. In future, I will have many doubts. I will ask you.
Yeah, sure. Okay. So that's all about today. Let's meet for the week 6 revision in the next class. Okay.
Thank you, ma'am. Thank you.
Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am.